Okay, now let's take a look into the next example. Okay, in the textbooks, the following figures shows the amount of coffee in ounce filled by a machine in 6 randomly selected jars. Assume a normal distribution for coffee in a jar with population standard deviation 0.229 ounce. At the 5% level of significance, is the true mean amount of coffee filled in a jar is not 16 ounce. Okay, so based on the information given, apa yang dia bagi raw data, betul tak? So apa yang perlu buat, you need to calculate the x bar and standard deviation by using SD mode. So we get x bar equals to 15.95 and sample, since here it's already mentioned the population standard deviation, so we don't have to calculate the standard deviation for the sample. Okay, so n we have 6 and alpha here is 5% or 0.05. So they want to test, okay, at the 5% level of significance, is the true mean amount of coffee filled in a jar is not 16 ounce. Okay, so keyword kat sini not. So not here, the symbol or yang kita akan gunakan adalah not equal. Kalau contoh yang tadi tu, it's clearly say that less than, betul tak? Okay, yang ni not, so symbol dia adalah not equal. Okay. Okay, so our hash naught and hash 1 here for this example, hash naught mu equals to 16, mu not equal 16. Okay, since the symbol we use here is unequal, so this is two-tailed test. Next, we calculate the test statistic. We're going to use Z because we know the population standard deviation. Okay, even though the sample size is small, but since we know the population standard deviation, still we should use Z. So we get Z equals to negative 0.5348. Okay, next, third step, find the critical value. Okay, again, since this is two-tailed test, remember you need to divide alpha 0.05 by 2. So we get 0.025. So this value should refer to the standard normal table. So we get 1.96. And remember again, put plus minus sign because this is two-tailed test. Okay, now we want to state the decision rule. Okay, the decision rule is reject hash naught if test statistic is greater than 1.96 or test statistic less than 1.96. Okay, why we come up with this rule? Okay, look at this figure. Okay, since this is two-tailed test, so our rejection region should be at the left and right. Okay, so this is our rejection region. At the right side is 1.96. At the left side is negative 1.96. Okay, so we will reject hash naught if our test statistics fall in these two, in this rejection region, either one lah. Okay, so look at the Z value that we get. We get negative 0.5348. Okay, so the value is, let's say, is here. So it was not in the rejection region. So since the value is, since the negative 0.5358 is greater than negative 1.96, so we do not reject the null hypothesis. Therefore, the test is not significant. There is no significant evidence to indicate that the mean amount of coffee filled in a jar is not 16 ounce. Okay, so kita boleh katakan mean dia adalah equals to 16 because we failed to reject the hash naught, right? Okay. Now we look into the same example, but by using the p-value approach. Okay. Step 1, we state the hash naught h1. Step 2, we calculate the test statistic. We get negative 0.5348. Okay, so from the test statistic that we have calculated, we get negative 0.5348, right? So look at the standard normal table, 0.53 the probability value is equivalent to 0.2981, right? But for this case is slightly different because this is two-tailed test. So what should you do is we need to times 2 the probability value that we have. Okay, so 2 times 0.2981, we get 0.5962. So the p-value for this example is 0.5962. So the decision rule is reject hash not if p-value less than or equal alpha. So since we get p-value 0.5962, which is greater than 0.05, so we do not reject hash not, or we fail to reject hash not. Therefore, the test is not significant. So what the conclusion is, there is no significant evidence to indicate that the mean amount of coffee in a jar is not 16 ounce.